What's up, everybody? I'm Matt Gary, and in this 17th and final episode of the Separation of Concerns in Apex Common tutorial series, we're going to go over how to implement unit tests using the Apex Mocks library. Alright guys, so on this 17th and final episode of the Separation of Concerns in Apex Common tutorial series, we're going to go over how to implement unit testing using the Apex Mocks library. So, if you don't know what Apex Mocks is, basically it is a mocking framework that allows you to create mock instances of classes for unit tests. And it's, as it states here, derives its inspiration from the Mockito framework, which is very popular in the Java language. So, why is it beneficial for you to potentially leverage Apex Mocks instead of other mocking frameworks that are out there, like Universal Mocks or whatever else? There's a handful of pretty good ones out there. Well, if you are using the Apex Common library, you have to install Apex Mocks, as the Apex Common library has some dependencies on Apex Mocks. And it's a pretty inclusive mocking framework. I mean, you can pretty much do anything you want to do on it. So it's not like you're really selling yourself short or anything along those lines. Not to mention, it again has probably the most support at this time for any mocking framework, and the most contributors, so you can, count on it being up to date with the newest things that Salesforce makes available to you, so that this, that this mocking framework is leveraging the tools that it should be, I guess. I know that there's also, before we get into an actual example of building a mock class, building a unit test using Apex Mocks, I also want to just state there seems to be a lot of confusion whether or not Apex Mocks uses the Stubbed API. It does, and it has pretty much since the Stubbed API came out. So Apex Mocks was made way before the Stubbed API existed, and so in its original implementation, it didn't use the Stubbed API. Now it does. This is very important. You don't want to use, you really don't want to use a mocking framework that doesn't leverage the Stubbed API. Then I'm not gonna get into that, but just know that that's important, and know that Apex Mocks does. Some people seem to think that I've spoken with in the past that it doesn't leverage it, and that's just simply untrue. So, all right, we've gone over why. We've gone over a couple other things. So let's go on ahead and build a mock, or basically a unit test using Apex Mocks. Now, if you don't know what a unit test is, or you're confused about unit tests and mocking and all that kind of stuff, please go watch the previous two videos, episodes 15 and 16, where I go over those things. That way, hopefully, you won't be as confused. Hopefully. I mean, no promises, but I'm trying. I promise. All right, so we've got this task service implementation class that I feel like I've gone over before, but maybe I haven't. We'll just go over it briefly. Basically, it's an abstract task service that allows you to create tasks for any object, and it leverages the application factory that we've built and talked about in episodes 4 and 5, the selector layer, a unit of work, etc., etc. And basically what it ends up doing is it ends up creating tasks for whatever object it is that we are currently working with in this task service. So we want to make a unit test for this class, and we're going to make it using the Apex Mocks library and go through kind of how it works. So we're going to call this class task service simple test, and I'm going to call it 2 because I already have one, and I've got it over here so I can look at it and make sure I'm not saying anything ridiculous, just like with all my other videos, to hopefully speed this up and save you some time. All right. So the first thing we're going to go over is how to actually create a mock class. Now, if you didn't watch the last episode, you should, because it goes over the need for separation of concerns to do mocking. But we will go over that a bit more while we work through this. So first things first, we need to make sure that we mark this as a test, and we're going to create a test method, and we'll call it whatever the name of that method was, private static void create tasks. And then I like to name my test this way. This has nothing to do with this video, but basically we'll say case task success underscore unit test. So that way when I come back in here, I know that I'm calling the create tasks method, like I'm testing that create task method. I'm testing a success for the case object, and this is a unit test. It's not an integration test. For me, that works. For some people, it might be too long of a name. Either way, it's irrelevant. Just know that's my thought process. So the first thing that we will need, I'm going to close a bunch of these windows because they're not super important, I don't think. The first thing that we need is to create some cases, right? Because the first thing that we do is we actually select objects that qualify for tasks, more or less. And so we're going to set up a case object for this. So for a case to already have theoretically existed, we need an ID. And so we're going to create a mock case ID. And this is the first thing that we're going to leverage. The first thing that we're going to leverage in the Apex mocks library. It's called the fflib ID generator. And basically, what it's going to do for you, if you call the generate method in it, is create a legal ID for the S object type that you pass. So I want to create an ID for a case, so I pass it case.SObjectType. This could be any of the objects in your org, whether they're standard objects or custom, right? You'll just pass it the name of the object.SObjectType, and it'll give you a legal ID to use for everything else. The next thing that we're going to create is a set of IDs, and the reason that we're going to create a set of IDs is because we passed that in to this create tasks method, so that's important. So we'll create a set of IDs called case IDs, and we will, you know, maybe I can type today, but there's no promises. And we'll give it the mock case ID. And last but not least, we're going to make a list of existing cases that we can have fake returned from our selector layer. And we're going to go over everything in great detail, I promise, but one thing at a time. We'll set the ID to the mock case ID, and we will set we'll just set some other random fields. We'll set this to high. We'll set the status to new, and we'll set the origin equal to email. Email. Cool. So now we've got a list, or sorry, a set of IDs, a list of cases, and a mock ID, which is all good stuff because we are going to need that in just a moment. So the first thing that we need to do, now that we've got our fake ID set up, Sorry, that's just anyway. Now that we've got our fake ID set up and we've got our set that we're going to pass to our method and our case list, we're going to go ahead and create our mock instances of our classes. So basically, what we're about to do next is actually create the fake instances of our classes that the task service impl class actually depends on. So our object domain, our selector, our unit of work, all those things. All right, so let's check it out. So we're going to say fflib apex mocks, and you can of course name this whatever you like. Let's make a new instance of the apex mocks class. Boom. Now we need to basically create a fake version of our class. So let's see how we do that. For our unit of work, we'll say fflib SObject unit of work equals a mock unit of work. That's equal to our, there it is, mocks.mock fflib SObject unit of work class. So without going into extremely great detail, basically what this does is it says we want to create a fake instance of this fflib SObject unit of work class, right? That's effectively what we're doing. We're creating a fake instance of this SObject unit of work class, and then we're assigning it to an actual instance of a unit of work, which is pretty cool. Now we're going to do that for the other classes that we are also going to leverage here, which is the cases domain, or the case domain. Cases mock case domain equals cases mocks.mock. Again, here we're making through that mocks.mock call, we are making our fake instance of the class. And we're going to do that one more time for the selector layer. So we'll call mock case selector and set that equal to case selector mocks.mock case selector.class. Oh, okay, I'll just do that. Okay, so now we have a mock version of all of the classes that the task service impl depends on. Our SObject domain class, so our cases domain is what would dynamically get instantiated here, our selector layer, and our unit of work. The next thing that we need to do after we create the mock instances of these classes is create basically fake returns from these classes, so from these classes methods. So whenever the class that we're really testing, this task service impl class, whenever the class that we're really testing actually calls these fake classes methods, something is returned to them. So let's check out how to do that. Creating fake return results from methods is called stubbing. So what you'll see next is us creating stubs for our classes, or for our classes methods. So we're going to say mocks.start stubbing. And just to be super safe, I always do this immediately where I say mocks.stop stubbing, because you need a start stubbing and a stop stubbing. If you don't stop your stubbing, you'll be in trouble. Things won't work. So we want two calls here, one to start stubbing, one to stop stubbing. And now what we're going to do is for these fake versions of our classes here, we're going to create fake return results for those classes by using what's called stubbing. So the next thing that we'll do is we'll say This gets a little confusing, so bear with me. I'll try and explain it the best I can. We'll say mocks when mock case selector dot SObject type then return case dot SObject type. All right, so let's just break this down. Basically what we're saying is for our mock class, for our mocked classes, when the mock case selector's SObject type method is called, we need to return the case SObject type. That's all it's saying. So effectively what will happen is when this method gets called by the task service impl class, it will just immediately return this result of case SObject type. If I wanted it to return a count SObject type, then I could do that. The code won't operate in this case. Well, it could depending on our scenario, but anyway, so that's all it's doing. It's saying when we call this method, then return this value, more or less. So the next thing that we'll want to do is set these fake returns up for everything. So we'll say when mock case selector dot select SObjects by ID, case IDs, then return our case list. So in this instance, when we call the select SObject by IDs with the case IDs, these guys that we set up, this fake set of case IDs, then we should return our case list. So that fake case list we set up. So now this basically this mocked class is prepped to respond when this select SObject by ID method is called to return a case list if these case IDs are passed to it, right? Again, we're just setting up fake return results for these different methods that are called by our class that we're truly testing. So we'll keep working through these. I like to indent these. There's no reason that you need to, but I just like things in a very particular way, I guess. Select SObject, or select records for tasks is eventually called. Then return our case list again. And oh my gosh, I just used spaces. Then mocks.when mock case domain dot SObject type return case dot SObject type. Slowly but surely we'll make our way through this. This one, okay, actually this next one that I'm going to do, we should talk through a little bit. All right, so a couple things that are important here. If you're using the Apex Common Library, when you initialize a selector class, it's going to call this SObject type. If you're doing it through the, well, actually we'll come back to this. Let me go one step at a time. But basically, you're going to need to mock these two methods, regardless of if your class that you're actually testing implements these methods like outright. There's some stuff in the background that fires these two methods for the case selector, or for the selector layer, just to prep it for what might come in the future, or what it needs information about in the future. And then this case domain, or sorry, the domain layer, it's also going to need you to prep this SObject type method here. So make sure that you do that if you're using those layers and you're using the Apex Common framework, or else you're going to get a bunch of weird errors that say, hey, this method had no return result and I'm getting null, and you'll end up getting null pointers everywhere if you don't stub these three methods that I have here. Very important stuff. Extremely frustrating if you've used Apex mocks and you're like, what the hell is happening right now? Why am I getting null pointers everywhere when I try to use Apex mocks with Apex Common? But that's really it. Those are these three weird methods. I guess they're not really weird if you go look at the code, but these three methods have to be stubbed or you're going to get null pointers and be very frustrated. And I just did it again. Okay. The last stubbing scenario that I want to show you guys is how to basically create fake exceptions being thrown, right? And this is super useful because in regular test classes, in integration tests, ones where you don't fake return results or anything like that, this can be borderline impossible sometimes to test all of the exception handling that you might be doing. So one great example that I like to bring up is every once in a while there are scenarios where you actually have to catch record locking errors. You know, there's just nothing else you can do except for prep your code for the scenario where it might every once in a while hit a record locking error. And if you're trying to test for that, it's basically impossible to reproduce. So mocking comes in a lot of handy when you have to deal with like testing that, yeah, my exception that I'm theoretically going to have thrown at some point is going to be caught, and I'm going to actually handle it the way I anticipate it. So the way that we do that, well, I'll show you two different ways. One for a method that returns void to you, and then one that actually returns results like the ones that we've been looking at here, just these guys. But let's take a look at how to throw a fake error or stub a fake error for a void method first, because this one is very confusing. It took me a little bit of time to figure out, to be honest with you. And again, I don't think that's because this is all that confusing. Actually, it's just more because there's not a ton of like excellent documentation on this library. So if I am doing error, wanting to throw a fake error on a method that returns void, I'll do mocks do throw when, and then I'll pass it the exception that I want to throw, and the class that I'm going to be doing this error throwing situation. My gosh, can I speak today? I'm not really sure. And then at the end here, I'm going to call commit work. All right, I think I maybe did this right. fflib SObject unit of work. I'm not sure why it doesn't think it knows what this is. Unless I just initialized it wrong. Oh, there we go. I typed something wrong. So basically what we're doing is we are casting this mock version of our class, telling it that when this class is called, we want to throw this exception, and specifically we want to throw that exception when the commit work method is being called. So this is a very confusing setup, and I'm not gonna go into the technical details of it because it would take a while to explain, at least from me. And basically what you need to know here is you need to call the mocks method, or use the the Apex Mocks instance that you have, mocks, right, this guy. And on it, you need to call the doThrowWhen method, throw whatever pass in whatever exception you think you want to throw, pass in the mock class that this is relevant for. Then you need to cast this as a whatever the object is you're basically eventually going to come back with. So for us, for a unit of work, that's fflibsobject unit of work. If it was the case selector, it would be case selector in here. Then you wrap this whole thing in parentheses and call the commit work class, or commit work method in the mock unit of work class. This is super confusing, but basically this stubbing situation going on here records that more or less when you call the mock unit of work class and you decide to call the commit work method, it's going to throw a DML exception. Let's just make it simplified like that. Don't worry about all the other stuff. Just worry about the fact that when you call this commit work method, it's now going to throw a DML exception. Cool. The other stuff is considerably less confusing. Oh my gosh, I don't know why I like to do that when I'm doing videos. It's pretty much the same as the other stuff. So if you actually have a return for your method, this is way less confusing to do. You just say mocks when, we'll say mock case selector dot select it did domain. Mock case selector dot select records for tasks. Then you just say then throw, and then you could do a new DML exception or whatever exception it is you wanted to do. So this is way simpler, right? If you're returning something from your method and you want to throw an error, this is a lot more straightforward of a setup. But if it's void, you've got to do this weird thing. So I just wanted to point that out because it is kind of confusing, especially if you've not done mocking a lot, especially even if you do this in other mocking frameworks. I think this, I will say, is one of the more confusing setups for this scenario, but it still works just as well. So okay, so we've got everything set up. I'm going to comment this line out because I don't want that to actually run. And the next thing that we're going to do is see how we use Apex, or really how we use mocking with the application factory class that we set up way back in episode 3 and 4. This is when we talked about this guy, the application factory, unit of work factory, all that kind of magical stuff. If you're using the Apex Common Library, you have this at your disposal to use, and it is well worth the time and investment to use it. It makes your code very abstract, and it's just a magical thing. So we're going to see how to set it up using the application class, and it's pretty easy, right? We'll just say application dot unit of work dot set mock, and we'll set the mock with the mock unit of work that we created up top here, that guy. And that's it. You're going to do that for each of your layers. So you'd say application dot selector dot set mock selector. Same situation for each layer that you're wanting to set a mock for. Mock case domain. And then what will happen is whenever these get called over here in the create tasks method that we're going to end up testing in the task service impl class, you're going to have this call return to you a mock. This new instance is just going to return a mock instance of the class that you've set up for it here. And that's it. Pretty simple. If you didn't watch the last episode, you should, because you can see how much easier this makes it for your class setup than if you had to do dependency injection in every single class. If you don't use this application factory that we've set up here, then you have to do dependency injection for all your classes, and it requires a bunch of restructuring and stuff like that. Not that this doesn't, but it's just, you know, it's a lot of extra work, I guess, than going down this path. So, a couple things I want to point out. You need to make your fake data that you want to use first. Then you need to make the fake mock instances of your class. Then you need to make the fake returns, basically, for your class's methods that will be called. And then, and only after those are all set up, do you set the mocks in your application class. If you do this before the stubbing, then these stubs will not be a part of these mocks that you set up, and you'll be very confused and frustrated. So make sure it's in this particular order, or you might be pretty sad eventually. Very frustrated. All right, so we are faking an error being thrown. So I just want to set this up to deal with it. If you've never done errors being thrown, or, you know, testing for errors to be thrown, then I guess you wouldn't know that you should probably wrap that in a try catch, because when you call the class, it's actually going to throw the error and, you know, bomb. But if you're testing for an error throwing situation, make sure that you wrap your actual method call in a try catch. So what we're about to do next is actually do the real test for our real non-fake or non-mocked class, and that will be the task service impl dot, oh wait, I need to do, sorry, new task service impl dot create tasks, and I'll pass it my, whatever I call that, case IDs. Cool. And then I will do a test dot stop test and catch our exception. And we will assert that we actually threw the exception that we wanted to. So we are throwing a real exception, even though it's, you know, faked. So we still want to know, right, that E is an instance of the DML exception that we said we wanted to throw. So we'll assert that and figure out if it is. If it isn't, it'll fail and cry and say, you know, get it together. This method also takes an S object type, so I'm going to add that there. And the next thing that we're going to do, well, actually, before we get into the verification methods in Apex mocks and how you can verify that methods were called or they weren't called and a lot of other cool stuff, let's just go over, or let's just test this and see if it works. Hopefully it does, but, you know, as we've seen plenty of times, when I code in front of you all, you never know what's going to happen. So we'll run this test, see if it works out, and it did, which is cool. And so what does that mean exactly? It means that all of these methods were stubbed successfully, that our assertion down here actually worked. We can further prove that by saying system debug we're oh boy, I'm gonna keep this simple. We're catching, since my fingers can't type, an exception, and save this and run it again just to prove that our error throwing is actually occurring. And hopefully somewhere in here we are catching an exception, right? And I've also got some other things in here for debugging, but that's less important. So you can see that we actually caught an exception. But, you know, if we commented out this line and decided we didn't want to actually catch that exception anymore, then we could run this test again, and we're not going to have caught that exception, right? No more exception in the debug logs, which you can hopefully see. No exception caught this time. So pretty cool stuff that you have the ability to mock all this stuff out and, you know, throw these fake exceptions if you wanted to, or needed to, rather. So the next thing that we are going to check out are the different ways that you can verify that methods were called, that things were done. So we'll look at verification, matchers, and counters, which are pretty cool. So let's start with something simple. We'll say maybe we want to test to make sure that in this unit test scenario that a method was not called. We will say cases. Maybe we want to make sure that a method on our domain class was not called. So we'll say cases mocks verify. So right now we're going to verify on our mock case domain that we never called this method, and let's see, what method should we call here? Handle after insert. We should have never called the handle after insert method, right? That definitely shouldn't have happened, so hopefully it didn't. And if this setup here is called a counter, so right now I'm saying I'm hopefully never calling this class, this method in this class, and if I did, then there's probably something wrong. I can also, for counters, add descriptions that say, hey, you weren't supposed to call this class, bruh. And then when I get, you know, if I accidentally call this class, or call this method, my goodness. If I accidentally call this method, then it's gonna, in the error logs down here, give me that description, or in the log files rather, it's gonna give me that description, so it's a little easier maybe for me to figure out what's gone wrong anyway. The next thing I want to do is verify that we actually called the register dirty method, which we should, because we've got a register dirty call here for cases. Not to mention in the create tasks, well, actually in create tasks we don't do that. We would call the register new. So we want to make sure that because we're an instance of cases that we actually had that register dirty method called. So let's check that out and make sure that that actually happened. And to do that, we're going to set this up in a very similar way where we say fflib I subject unit of work mocks dot verify, not verifying, but verify that for the mock unit of work class we called it mock times, we called it once, and and we want to register dirty method with the case list. So what is this doing? It's pretty simple, pretty similar. We're just saying that for this mock unit of work class, we only called this register dirty class with the case list attached to it or sent to it one time. That's it. So that what that mocks times is just the amount of times it was called. There's also a bunch of other things you could do, like less than, I think it's something along these lines. Let me double check my notes here and give you all the other. It's like, oh, that's what it is. There's at least. You could say it's called at least once, or you could, you could say at most once, or 3 times, or 20 times. You could say mocks between 1 and 5 times, or something like that. So there's a bunch of different ways to use the counters, I guess. Typically, the only 2 that I use are times and never, though, if I'm being completely honest. I very rarely, if ever, use this whole between situation, or the at most or at least. Anyway, that's what this mocks times does. It says, for the mock unit of work, let's verify that the register dirty method was called 1 time with the case list attached to it. Cool. And you could also add a description here if you wanted to. I'm not going to maybe save you a few minutes. And last but not least, let's do a verification on the create task method, the kind of star of the show, hopefully. And we'll say mocks.verify mock domain. It's called mocks.times 1. It's also worth noting you don't technically have to do this. If you leave that blank, it's going to assume you only wanted it to be called once. And if it gets called more than once, it'll complain. And if not, it'll be cool. You also have the option to just do that. And then you don't have to use that mocks.times setup either. Got a bunch of different options if you want to use them. And we'll call the create task method and pass it the case list and the mock unit of work. So, pending everything goes okay, and we've mocked this out the way that we wanted it to be mocked out, these should all come back true. But I will show you in a second what would happen if they failed. Pending I didn't screw something up already. So we'll save this, and as soon as it's saved, we'll run this. Oh boy, I guess I clicked something quick enough. So it ran that test. I'm going to run it one more time since that was super fast. But it ran that test and seemed to handle it okay. So it looks like all of our verifications were good. But say, for instance, this one that I wanted to call never, I called it once. Or I wanted to see if I called it once. Or rather, I expected it to be called once, but it shouldn't have ever been called, and it isn't. So in the case that that happens, what you'll end up seeing is the case, this test method fails. And it's failing because it expected a count of 1, but we actually only called this method 0 times, right? And we got our description back that says, hey, you weren't supposed to call this method, bruh. Right? So in the case that one of these actually does fail, your test will actually fail, and you'll get some information about what it was expecting as opposed to what it actually did find for the handle after insert method, right? Pretty cool stuff. All right, so one last thing that I want to go over. There's a lot of other cool things in Apex mocks. But one more thing that I want to go over is the matching that you can do with mocks. And it's a kind of a confusing name, if I'm being totally honest with you. It's a little confusing, but it's very useful. There's a lot of things in mocks that are useful, but they have a little less benefit to them than this. Pretty powerful thing, I think. And I don't think a lot of people that even use this actually know how to use matching. So let's go over this. If we go back to my task service implementation class, back up here you can see that if I'm a list of cases, before I actually call this register dirty method in the unit of work, I'm supposed to have updated the subject from whatever it is to by, right? I'm only doing this as an example for this video, but you'll notice that I'm verifying that I called this with the case list, right? This case list up here. And that's fine and wonderful, but the subject is high, and I changed it to by up here. So the question is, I guess, how do I know for sure that by the time this register dirty method was called here, that I actually had the subject updated, right? And that's where matchers comes in, because what it allows you to do is identify whether or not you could verify that the class, or sorry, the method in this unit of work class was called with that updated information. So let me just show you how this works. You have to basically create a new list of cases, and we'll call it the case matching list, and we'll set it equal to a list of case, and we'll call the fflib underscore match SObject with, and we're going to pass this well, we're going to pass it a list with a map in it, basically. So we'll say new list map schema dot SObject field to object, and then we are going to create this map, which I think we need one more bracket for. Alright, schemda. New list map schema SObject field object. Let's make sure I didn't do anything too crazy. Nope. I just need to now in here say new map SObject field object. Oh boy. Alright, I think that's it. We'll see if I screwed this up. Okay, so what does this do exactly? This is going to basically record a matching scenario for, how do I say this in regular words? This is always the tricky part. Basically, this is this matcher that we're creating, this thing right here, is going to allow us to pass into this verification method down here this updated, this updated list of cases that are going to have the actual values that they should have by the time that register dirty method is called. So let's just give it a shot, see what we get here. I'm gonna say mock case ID, and this should be case dot subject equals by case dot status equals new case dot origin equals, or is mapped to email, really. All right, let's see what I messed up here, if anything. fflib match SObject with new list map schema SObject field object boom, boom. New map of SObject field object. I think we're good. I think it's just confused. We'll save it and see who's right and who's wrong. Probably me, but it's me. What is it complaining about? Method does not exist or... Oh, correct. Yes, objects with. Woo. It's a tricky one. Alright, so you can see that more or less what we're doing is creating a case that has these fields mapped with these values. So the case ID is mapped to the mock case ID. Case subject is mocked with the or is mapped to this by, which is what it should end up with here. And then we've got status, origin, etc. And now what we can do is here where we look for this register dirty method and verify that it was called once, we can also verify now that it was called after the updates happened, right? Before we weren't really like verifying that this was indeed called after the updates happened. Now we can do that. So before I move on, I want to, or before I press the test button and we watch this fail, I want to explain what's about to happen next. Matchers are great, but they're a little bit frustrating, at least with this library. Or maybe I just have a misunderstanding, and someone feel free to correct me if I'm wrong here. But because this verification call here is using now a matcher, right? This matcher that we've defined. These other verification methods are going to fail. And they're going to fail because I'm not using matchers in them. So if I run this now, you should see, yeah, you'll see it complain about the fact that I'm not using matchers. It's going to tell me that somewhere in here, the number of matchers defined does not match the number of expected. If you're using matchers, all arguments must be passed in as matchers. Blah, 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 blah. And it gives you an example and some stuff. Now, you'll notice that if I comment out these two methods that aren't using matchers, and I save this, then if I run this again, it'll be good to go. So if you are using matchers, just know that while they are very useful, they can make your other verification methods fail. So normally, to be honest, a lot of the time I will split these into different things. If I need a matcher scenario, I'll put it in its own unit test method to make it a little easier on myself. But now you can see, like, so if I change this and I passed in the matcher high, which is what we were looking for before, right? It'll tell me, no, that's incorrect because it was actually modified before then, right? So now I'm putting in the word high, which, as you can see, originally is what it was declared as up here. But our test method failed because the matcher was like, nope. The actual arguments were subject by, and you passed in a subject of high. So it does indeed verify, despite the minor frustration, that we actually updated those cases before we called this register dirty method, as we expected over here, right? So pretty cool stuff. Now, this is definitely by no means the only stuff in Apex mocks. There's a lot, and I mean a lot, of useful stuff in here. So if you want any more information about Apex mocks, then definitely head over to this wiki page that I've made for it in this Salesforce separation of concerns in the Apex Common Library Git repo. And it's got more information on a whole bunch of other things. So, you know, more information on stubbing, which we went over earlier, verification methods, matchers, which we just went over, exceptions being thrown, how to mock those, answering. I did not feel like I needed to write up a new thing. There is a pretty good blog post about answering that I've linked out here, how to check method call order. Also, there was a surprisingly good blog post about that, so I'm linking you out there so you can get more information about method call order if you want to check that your methods were called in order A, B, C, D, E. More information on counters, and more information on how to generate fake data in different situations. So, and then there's, of course, this impl test that we just built together that is in this library too that you can reference later. So, lots of good stuff. If you're lost or you want to learn more about Apex mocks, it's all in here. I hope at least the majority of it. So hopefully you guys find it useful. That, I think, finally wraps up this series. And you can go on with your life, and I can go on with my life. And it's great. 2 months of work. Finally over. Alright guys, I hope you enjoyed this video. I hope you enjoyed the series. Hopefully it has helped you on in multiple areas. You know, what separation of concerns is, how to use the Apex Common Library, different patterns that are useful to you for not just the Apex Common Library but other places, mocking, whatever else, all that kind of stuff. Hopefully it helped. I know I learned plenty. So anyway guys, that's it. Thanks for sticking with me. If you really watched every single one of these episodes, that's amazing. I appreciate it. So I will see you all in the next regular episode, because I don't think I'm doing a series for a while. Alright, see you guys later.